Today we are going to introduce our research on supporting interactive data management over a read-only data store. So suppose there's an RMDB dataset with more than 800 million of rows. To store this dataset, a group of customers choose Hadoop as their distributed file system. Among those attributes, some cells in rows need to be changed dynamically since some movies are still showing in theater. So in this scenario, is there a way to efficiently modify this dataset? Our project aims to support interactive data management over a read-only data store. In specific, we are going to explore how to integrate Hadoop with existing DataSpread project. To solve the problem, we have two major insights. The first one we assume that user only looks at a small portion of data. Secondly, the updates manually done by the user are very small. And basically, we have four milestones listed. The complete ones are highlighted in red. For the first one, we will simply show our architecture design with explanations and a graph. For the second one, we will present a demo of our system. So here is the basic design. You can see here, customers can use a load button to read data from Hadoop and display them in our DataSpread frontend. Whenever users modify any cells of data, our DataSpread backend will store corresponding changes as a row column value format. You can see here. And next time the users reopen the Hadoop file through our software, we can retrieve these changes they made before and present the modified file in frontend. This is how we integrate Hadoop with DataSpread. And we have two approaches. First of all, to support read from Hadoop into DataSpread, we leverage window function to improve reading performance and positional indexing to improve uploading performance. By using DataSpread window function, we only load data which can be presented in current window size, so that users will not meet a huge lag when loading the data at the first time. In addition, we adaptively create partial index for Hadoop and build a new layer of type mapping to match positional index in DataSpread, so that we can choose any lines of Hadoop file to present. Secondly, to support restore changes from DataSpread to Hadoop, we load all changes which belongs to current window into memory. When users scroll up and down, we continually store changes into memory. It is very fast due to in-memory operations and only requires a few memory space since users may not view all data. Finally, we have some results for now. So by creating indexed file in Hadoop, we can access and get any lines of code and files and data in Hadoop within a small amount of time. By testing on the VM, we show that the reading time is constant with the growth of number of lines fetched and will not be affected by the starting position.
We already fired up the Hadoop server and the DataSpread server. So firstly, let's load the data file to the DataSpread from our Hadoop data file system. It will take a few seconds to load the data. While waiting, let's check where I store the actual file. So I store the file in our Hadoop data file system. So actually the file is here. It is from IMDb 5000 dataset. We replicate this dataset for a few times so that this dataset actually contains more than 10 million rows, and that means it also contains 10 columns. So in total, it contains 100 million cells. So right now, the data has already uploaded into our DataSpread, and we can scroll up and scroll down to see all of the actual data in this Hadoop file. And actually, our performance is really good. As you can see, if I scroll to an arbitrary line, it will take only 2 or 3 seconds to read all of the current lines. And here I can scroll to the end of the file. It also takes only 2 or 3 seconds. And this is mainly due to the network connection because we need to read data from our Hadoop file system.